From today's we will start the in electronic devices and circuits. We will discuss the module first, that's of, of electronic devices and circuits. First we will discuss about the clamper. What is the clamper? First we should know clamper is electronic devices that use to clamp the output beyond the present value or voltage level without varying a remaining part of input of waveform. Suppose that this is the input waveform. This is the input waveform. We want to clamp this input waveform from here to here and again here to here, like any forms clampings. This like this like this, and this. So clamp the out inputs at the output level is called it clamper. The working of clamper. A clamper circuit can be designed by utilizing linear and non-linear element. Linear element may be diode. So non-linear element diode or transistor, and linear element is a resistor. So the combination of linear or non-linear elements. As these circuits are used only for clipping the input waveforms, for clipping or cutting the particular levels of the input waveform, that's why clamper circuit is used. Each per our requirement and transforming the waveform, so they don't contain any energy storing element. Means they don't contain any energy. Suppose that this is the clamper circuit. It contains only one diode and one resistance. This is that it don't contain any inductors, any capacitor. So that's why it is a. We should know that clamper element should not contain any storing element like inductor, capacitor. In general, they lack inductor and capacitors. So in general, clipper are classified in two ways: series clipper and shunt clipper. In series clippers, again classified into series or negative clippers and series positive clippers, which are follows. In series clippers, this is the diagram of series clippers. So this is the diagram of series clippers, where resistance, where diode is connected. This diode, where this diode is connected in series with input, and you can say like in series in input. Why it is called a negative? Because the P, generally diode we consider generally this is the positive terminal of diode, this is the negative terminal. So negative terminal of diode is connected to the output voltage. That's why we are calling it series negative clippers. So above figures we can see this above figure we can see this figure. Suppose that this is the one diode, this is the output, here this is the input, this here to here is a VI. The above figure shows a series negative clippers with its output waveforms during the positive half cycle. Diode considers as an ideal diode. Here we have generally considered the ideal diode. Ideal diode means the voltage drop in forward bias is 0 and resistance is 0. This is if this is the diode, in ideal conditions, first we should know if this is the during the forward wise, it look like this simple here, only simple inductors. Drop across at 0 and the resistance must be 0. So this is the ideal diode considered in forward wise, and the conductor such as entire positive half cycle conduct entire positive half of inputs, and resistor are connected parallel shown outputs during the negative half cycle. Diode is reverse bias and no output across the resistor, so thus clip the positive half of inputs. So we can understand this concept here. How? Suppose that this is the input. This input, this is your input. This is the input we have applied. This is the Vi. When we applied this input to this diode, so during the positive half up to here, the diode as ideals means voltage drop across 0. So during the positive half, during the positive half, this circuit, this diode behave like a normal short circuit here, and input here is output, here are this input. During the all the during the positive half, all the inputs show like only positive half. This is the only positive half output. There is no clipping in this part. Again during the negative half cycle, this diode during the negative half cycle, so this diode become to reverse bias and diode become open. This look like this, diode become open. This is the V positive, V0. This diode become open, Vi input is here. If diode is open, so there is no current flow, so then output must be 0. So we can see the overall output of this circuit means, so this is the input waveform like this, and this is the output waveform. Output waveform, and during the this is the output waveform. This is the output waveform, or this is the input waveform. During the positive half, this input, because diode is forward bias, this input is still like this, only up to here. During the negative half cycle, is input become negative, this diode will be off and its output again 0. Up to here its output, it look, so complete waveform look like this. Complete waveform look like this. So that's why it's clip the negative parts. You see why this diode is named, why this circuit is named negative clipper, because this clip only negative sides. Like here, that's why it's, and by seeing the circuit directly we can say when diode N side is connected to the, means cathode of diode connected to the output, that's why it generally it's clip the negative inputs in this way. So this is the main concept of negative clippers. Then second is a positive clippers. Same circuit is there, only changes is this. Here one resistance is there. Here this is the one resistance, and this is the, during this diode, during the positive clipper, the anode of the diode is connected to output sides. In previous we are seeing that this, in previous circuit, this diode position like this, but right now diode position has changed. This diode become to like this, means diode cathode is connected to output. Previous circuit, that diode anode is connected to output side, but negative series clamper, that diode of cathode is connected to output side. Here in positive clamper circuit, diode anode is connected to the output side. So same concept in positive series clampers is connected above this figure. During the positive half cycle, diode become to reverse bias. During the positive half cycle, diode become to reverse bias. So means the circuit, so no current, so there is no, that time for input there is no output, and so no output is generated across the resistors. During the negative half cycle, diode is conducted, no means diode will be forward bias, and entire input will be appear here. So we can see here. So suppose that this is the input. Positive clamper, we can see this circuit in small details. Suppose that this is the positive clamper. This is the positive. This is the positive. This is the resistance, like this. This is the output voltages here. This is the input. Input we are connecting here. Okay. Output. This is the resistance. When we applied the input, so this is the input. Because our circuit look like this, we can draw the circuit here also. This is our circuit. Output we are taking here V0, and this is a negative circuit. Thick output we are taking here during the positive half cycle. During when input is positive, so this diode become to reverse bias. So there is no, so no, there is for input there is no output. For positive out, this is the output waveform. This is the output waveform. Up to here, in this cycle, the output must be 0, because diode is a reverse bias. During the negative half cycle, from here, this is the positive half cycle. During the negative half cycle, this diode become to on. So input directly appeared in output terminals. This diode look like this. This diode look like this. So that's why, because its positive part is in output, positive part is only clamped. So that's why this circuit is called it positive clampers. So this is the circuit. Next, the shunt clamper. In shunt clampers are classified negative, shunt negative clampers and shunt positive. In shunt and negative clampers, why we are using shunt? Because in this time, this diode is connected to parallelly with the output. Previously, that was output. We are taking output on is a parallel connection of diode compared to output. So in a negative shunt clamper is connected in shown figure. This is the negative shunt clamper, means the during the positive half cycle, the entire inputs. Suppose this is the, in this circuit, this is the input, this like this. Okay, this is the input waveforms. Here to here input. Suppose that for positive, and this is the, we are drawing output here. For positive input, up to here to here. For positive input up to here to here, this diode become to off, means to here to here diode become off, because for diode become off. For positive input, this for positive input, this diode will be in the reverse bias, because here diode is negative, here is positive. So for if we are having a positive input, this diode become off. This diode will be off. And so whatever input we are applying, when this diode become off, so this circuit behave like input, diode is off, and diode is off. Here we are taking a output, here is input Vi. So whatever input we are providing during the positive, that's complete input appear to the output. How? Because of this. During the negative half cycle, during the negative half cycle, this diode will conduct. During the negative half cycle, if this is a, if we are providing input from here, input like here, so during the diode, this diode is ideal, so this becomes a short circuit, and we are taking output. So that time output must be 0. That time output must be 0, because the circuit is clamping the negative inputs. That's why shunt negative clipper, shunt negative clipper. So one bit, and in short we can understood, when during the positive half supply, so this diode becomes to off. This diode becomes whatever input we are applying, same input we can see here. You can see here, same input we can see here. And during the negative half cycles, this diode become on. This diode become on. So this diode, so this is the ideal diode. So this path becomes shorts. That's why output must be equal to 0. Output must be equal to 0. So this is the waveform of, this is the output waveform of negative clippers. Next we will see the positive shunt clippers. This is the diagram. Only change between the means the diode position is reverse bias. In previous circuits, the output voltage polarity and input voltage diode polarities are same, opposite. Right now, in shunt positive, the output voltage polarity and diode polarities are same. That's we can say that the diode anode terminal is connected with the output voltage positive supply, and diode cathode terminal is connected with input supply. This is a shunt positive circuits. This is the shunt positive circuits. How this working? How we will see how this circuit will work. So during the positive half cycle, during the, we can see during the, this is the input. During positive half cycle, so this diode become, because positive half cycle, so this diode, during the diode look like this. During the positive half cycle, so this diode become on, and this diode become on. During positive cycle, this diode become on. This diode becomes, circuit behave like, so overall circuit diagram look like this. This is the diode is on, This is the input supply. This short, so this path becomes short. So this is the output here. We are taking the output, and here we are taking a input. Input. So output must be zero because circuit is short. That means from here to here, here to here, output is zero. This is a positive partition for positive negative circuit. For negative, if the input is negative, that time this for this inputs the circuits become like this. This is the diode is reverse bias because negative of this diode become reverse bias. In diode behave like open circuit. Here diode, so this was output. This is the input. So same input appear as output. Whatever input we have, so same. So this is negative input appear as same as output. This is the operation of the shunt clippers. So the different type of applications we can see, they are used for separations of synchronizing signals from composite pictures. Then for generation of new waveform we can use the circuits. So this is all about the clippers. We have study here four type of clippers. Series, we have studied two type of clippers, series and shunt. Within the series there are two type, positive series clippers and negative series clippers. Similarly, in a shunt capacitor we have seen two type of, first is a positive clippers, second is a negative clippers. Next topic we will discuss about the clampers. Here we have discussed about the clippers, but next topic is a clamper. Both are different. Until we have discussed the our lecture clippers. CLIPPER. Clippers means removing the inputs, removing some part of inputs is our requirement. But in the clipper, there is no remove. Clamper, there is no removal. It shifts the input one level at a different level at the output stage only. In a clamper, only shifting is done. In a clamper, only shifting is done. But clipper, in a clipper, we are clipping the input. We are cut the input is our requirement. So we can see the definition of the clamper. An electronic circuit that used to alter a positive peaks or negative peaks for input signals to define a value by shift the entire signal up or down to obtain a signals at desired level is called it clampers. Means we are shifting, we are not changing, we are only shifting the entire signal up or down to obtain a signal output peak desired level is called a clamper circuit. We have seen electronic circuit that is used to alter the peak negative inputs and defined to the, so in this circuit we are only shifting the output it up or down, not cutting the inputs. But clamper we are removing the some part of it. This is a difference. You should know, right? Working of this circuit we can see the working of clamper. The positive or negative peak of signals can be positioned at the desired levels using the clamper circuits. We can shift the levels of peak signals by using the clampers, hence it is called it level shifter. It's another name, it's called it level because we are shifting the output from one level to another level. That's why this circuit is called it clampers. So clamper in a clamper consists of a capacitors. This is the energy storage and resistors. This is the combination of two things. In clampers we have seen that is the combination of resistors or diodes, but clamper is a combination of capacitor plus resistance. Because we are shifting, because why we are using the capacitor, because we want to shift the input a desired level. So for shifting, the capacitor will restore the the energy. Based on that restore energy, we can shift the input at desired level. So Klepper circuit consists capacitor diode. This capacitor diodes in parallel across it a load. The clamper circuit depends on the change in time constant of the capacitor. How the capacitor time constant changes, based on this output is depend. The capacitor must be chosen so that during the conduction of diode, the capacitor must be sufficient to charge quickly. मतलब charging time capacitor must be quickly. Whenever diode is forward bias, it should be charge very quickly. So charging time diode should be very small during this period. During the non-conducting period of diode, capacitor should not discharge drastically. So charging and discharging capacitor must be moderate level here. The clamper are classified as a positive and negative clampers based on the clamping methods. So next we will see the negative clampers. This is the diagram is shown here. This is the negative clampers. In negative clampers, we can see in a positive half cycle. In a positive half cycle, this diode in positive half cycle, this circuit we can see that this is the diagram of in a positive half cycle. This diode circuit, because diode will be on. So this circuit diode, this part become to show this is the input. This is the VI. We are applying that. So this diode start to charging positive supply. This during the positive half cycle diode is on. So and this capacitor is charged. During the negative half cycle, how it will look like? During the negative half cycle, so during diode become to off. So this is the capacitor. During the positive half cycle, this capacitor has charged to VI. V input, VI. Capacitor charge, and right now this is the out. In negative of this diode become to off. So this is the output voltages here. This is the VI. So we can use the KVL in this circuit because this input is positive here, in this here positive, here positive. So first use the KVL. So we last terminal we can choose the, so for this input we can take the VI positive. For this input, VI can take so for this input VI can take negatives negatives. For this input Vi can take negatives and output must be negatives, because sorry, for negative half cycle this diode become, this out supply will be reverse bias, so it will not be, suppose, so we are writing a wrong here. Again we can take new slide here. So suppose that this is the, during the, during the positive half cycle, during the positive half cycle this diode has become charged up to V positive at the Vi, at the input level it is charged. During the negative half cycle this diode become off. So this diode during the negative half cycle, during the negative half cycle this diode become off. Here is a output voltage, this is the input, because input is a negative supply, so this means input supply positive or negative, because positive half cycle we have seen output is 0, so we can use the KVL here. So Vi, it takes the last, if we take last sign for each input, so this Vi is a negative, Vi is negative, okay. Again this Vi is also negative, we are taking last sign, and this output V0 is also negative for taking a last sign, last sign and last sign. This is the Vi output equal to, using the KVL, equal to 0. So we can say the output V0 equal to Vi minus 2 Vi, minus 2 Vi. During the positive half cycle the output was the 0, but during the negative half cycle output was the 2 times of inputs. So we can see the diagram of this output waveform of the circuit. This is the input supply here. We can, and this is the output waveform we draw here. During the positive half cycle up to here output was 0, because diode was the short circuit, so output become 2 shorts. The output was, during positive half output is 0. So during the positive output was the, so during the negative cycle output was a 2 Vi. This is the Vi. So the output was the 2 Vi. I think 1 second we can again. So during the positive half cycle input, and the input of diode is forward bias. During the input of diode is forward bias. So is diode conduct capacitor gauge charge up to peak voltage and supply. During the negative half cycle diode does not conduct, so output voltage become equal to sum of the input voltage and voltage stored of the capacitor. So during the, if we talk during the positive, how the circuit look like? During the positive half, this is a diode and this is the Vi, input supply Vi. V positive, this start to charging the short circuit. This is the, up to here is a Vi. Okay. So we can see how the outputs. We can use the KVL in this equations. So output is, how the output become, how we can calculate the output. So output is nothing but Vi equal to Vc. In this charge, Vi equal to Vc, voltage across the capacitor. In the circuit, during the positive cycle, voltage across the capacitor. So output must, and output must be zero during the positive half cycle. When input is zero, so diode initially becomes, when input is Vi, at that time output is zero. In negative half cycle, it becomes to two times. This is the negative half cycles, it becomes to two times. So next class we will discuss from the clampers again, because some